factorize in a number of different ways, right? So I can factorize by taking out a highest common factor. I can factorize by difference of squares. I can factorize a trinomial. And this particular question here, I'm just going to rub out the pink so that we can see it better, is factorizing by taking out a highest common factor. Can you see that? And what's common to both of these terms? It's simply going to be, say again?
X.
X, exactly, 100%. All right, so in question 1.1.1, the only way I can factorize this is to take X out as a highest common factor. So X times what will give me 4X? X times 4.
Ma'am?
Mm-hmm.
Ma'am, I took out an X and a 2.
You can't take out 2 because there's no factor of 2 here. That's a 1.
Oh,
okay, so you can't, so unfortunately you can't take out a 2. The only thing you can do is take out an X to start off with. But then things get interesting because now you've got 4 minus X squared. So that's not the end of the story, all right? Because what is inside the brackets is called, does anybody know? Does anybody know what's inside the brackets? What kind of factorizing we call that? Difference of 2.
Oh, difference of 2 squares.
Difference of 2 squares, Sam. Yes, difference of 2 squares. Okay, does that sound familiar to everybody else? Can you just give me a thumbs up? If
Yes.
you've heard that before. Yes, okay, thank you. So it would end up being like this. Okay, now Cecile, you're saying, ma'am, do you divide both sides with X? No, Cecile, we're not working with an equation, all right? This is an expression, all right? So in other words, we're not, yes, dots, Marisa, that's exactly it, dots, difference of 2 squares. Quite right, that's what this is. So in the bracket, it's dots, and that's how we would have to factorize it. Okay, so see here, we can't divide, we never ever divide by a letter anyway, because our letter could be equal to 0, and then it would make something undefined. What we are doing is we're factorizing, okay, Cecile, so that means that we are creating factors, right? So in other words, what things, when we multiply them together, would give us this expression over here. All right, so the first thing that you would have to do, grade 10s, is you would have to take out the highest common factor. The second thing that they would want you to do is factorize the remaining difference of 2 squares inside the bracket. Okay, that's a little bit different to the next question. The next question they want us to factorize as well. But what's that called? That sort of expression, x squared plus 15x minus 54. Does anybody know what we call that in maths?
Ma'am?
Yes.
Ma'am? Is it a quadratic expression?
It is a quadratic expression, quite right. It is, good.
Trinomial.
It's not a binomial. It's a trinomial, that's it. Okay, Cecile also said that on the chat. Perfect. It's a trinomial because it has 3 terms in it. It does happen to be quadratic though. Okay, so trinomial, the word trinomial means it has 3 terms. The fact that it's quadratic means that the highest power is 2. Okay, yes, factorizing a trinomial. So when we factorize trinomials, Cecile and everybody else, they always factorize into 2 what? Does anybody know? 2?
2 brackets.
2 brackets, Harry, that's right. Okay, so trinomials always factorize into 2 brackets. So what we're doing here is actually the opposite of FOIL. When you say the cross method here, yes, Cecile, you can with one like this. Right, so in other words, normally we use the cross multiplying method when the number that's in front of the x squared is something like a 2 or a 3 or a 4 or another number, right? But we certainly can do it here as well. All right, so we know in this situation here that we want x times x to give us the x squared. Now we need to think of two numbers. When we times them, we get 54. But when we add them or subtract them, we're going to get 15. Okay, so start thinking about the factors of 54. All right, so we're not going to use 1 because 1 and 54 cannot make 15. We're not going to use 2. 3 is not going to work. 4, 5. What about 6? Isn't 6 times 9 54?
It is.
It is, that's right. And 6 plus 9 is 15, isn't it? Okay, so now our bracket, it's negative. Oh, but hang on a second. We've got a negative at the end here, and we've got a positive over here, which means that one has to be minus and the other one has to be plus. So the problem is with 6 and 9, something is not going to work. All right, so because if we have 9 here and we have 6 here, if you use 8, that's what we're going to have to use in this case, Harry. Okay, I'm just showing the others. There's your cross multiplying method. Now, the reason that 6 and 9 doesn't work here is because if we want plus 15x in the middle, both of these have to be plus. But we want a negative at the end. Okay, so if we multiply two positive numbers together, we're not going to get a negative. So that means that here, 6 and 9 do not work. So Harry's made a suggestion. Harry said, what about 3 and 18? Yes, Harry, I agree with you. All right, so if I put 18 here and I put 3 there, and then I cross here and I get 3x and I go down there and I get 18x, and now I go back and I fetch my middle term. And now here I've got 15x. Which one needs to be positive, Harry? The 18 or the 3?
18.
Exactly, Sam. The 18 needs to be positive and the 3 needs to be negative. Okay, quite right. So in the brackets, x plus 18, x minus 3. Okay, does that make sense to everybody? Are there any questions?
Ma'am, isn't the 18 greater than the 3? Why is it taking the plus sign?
Because your middle term is positive, Marisa. So if your middle term is positive, then the bigger of the two factors has to take the positive sign. Does that make sense to you? Because what you're going to get here, my girl, is you're going to have plus 18 minus 3 to get plus 15 overall. Okay, Marisa? If it was minus 15, yes?
Ma'am, so the the bigger number takes the sign of the middle term. Is that what you're trying to say?
For this particular case, yes, but not for all cases. All right, so it depends on what it is that they have given you, because they can give you, hang on a second, if we're talking about trinomials, just give me 1 second and let me move the board over. All right, so if we're talking about trinomials, we've got 4 different types of trinomials that we can have. So let's say we've got x squared plus 7x plus 12. Okay, this is essentially type number 1, where our middle term and our last term are both positive. Okay, so when this factorizes, it's easy because both brackets have to have a plus inside. Okay, in this case, the numbers that we would use would be 3 and 4. Okay, so x times x is x squared. We're doing the opposite of FOIL. X times 4 is 4x plus 3x gives us our 7x in the middle. And positive 3 times positive 4 gives us our positive 12 at the end. So that's type number 1. Okay. Then we've got another type. Okay, so let's do this in a different color. We've got type number 2. And here, I'm still can use this one. The middle term is now negative. Okay, can you see how the middle term here, when I say the middle term, I mean the x term, it changed sign. So when the middle term is negative and the last term is positive, both brackets are minus. In this case, it's going to be -3, -4. Okay, again, remember we're doing the opposite of FOIL. So if we just double check our answer, x times x gives us x squared. X times -4, -3 times x, that gives us -4x minus 3x, which is our -7x in the middle. -3 times -4 is +12. Now, let's just clear a little bit more space here and move over. Unfortunately, it's not just this simple. Okay, so now let's go with, let's just use a different color. Type number 3. And let's think about this carefully. So if I've got x squared, let's say I've got x minus 4, and then here I've got x plus 3. That would have given me x squared minus x minus 12. Let's say I've got one like that. Okay, so now the middle term is negative and the last term is negative. So here, one bracket has to be plus and the other bracket has to be minus. Because the middle term, the one that I'm drawing the circle around right now, because that is negative, the larger of the two factors, so in this case 4 and 3, the larger number 4 had to be the one with the negative sign. Because to get this middle term, okay, remember we're doing the opposite of FOIL. Okay, so to get this middle term, it's this together with that. So positive 3x minus 4x gives us the minus 1x in the middle. Okay, so when the middle term is negative and the last term is negative, one bracket is minus, one bracket is plus. But of the two factors, the larger factor is the one that has to be negative. Okay, now let me show you the fourth and final type. I hope you can see the screen, type number 4. Okay, and then here I'm just going to use completely different numbers. So I'm going to say x plus 5, x minus 2, and then there the question would have been x squared plus 3x minus 10. Now, this is different from the others because the middle term is positive, but the last term is negative. Okay, so when the middle term is positive and the last term is negative, again, both brackets have different signs. But because the middle term is the positive one, the larger factor is the one that takes the positive sign in this case. Okay, so that is something that you have to know and learn from when you are in grade 9. Now, unfortunately, your grade 9 year was a horrible year for you guys because you were in lockdown and you didn't spend a lot of time at school, okay? But those are the 4 different types of trinomials that you get when it comes to science, and they would expect you to be able to factorize all of them. Are there any questions? Is there anybody who wants to ask me anything at this point? Does that make a little bit more sense to everybody? You happy with that?
I have a question.
Sure, Marisa.
Ma'am, is it possible to use those signs like a negative next to a negative equals to a positive, positive next to a positive, it's a negative, things like that? I'm not sure. I'm just asking.
I don't understand in what context you're asking, Marisa. Are you talking about when you're multiplying, or are you talking about if you're adding or subtracting? In what sort of question do you mean?
Ma'am, I mean, how can I put it, ma'am? In this example that you gave us, type 3, you say x squared minus x minus 12. So then
Yes.
is it possible to say the negative, I mean, because there are two negatives here, is it possible to say equals a positive, like it's like also the multiplication?
You see, the reason why you have a negative middle term and a negative positive, a negative end term, is because you've got a negative number multiplied by a positive one, right? So in other words, like let's say, so this is the opposite of FOIL, Nzole. What we're doing is the opposite of FOIL, okay? When we do FOIL, let's just go through this again, right? So just hang on, I'm just going to grab the pen, all right? When we do FOIL, then the instruction would be simplify. So if they told us to simplify, and the first thing that they gave us was this, then this means FOIL. Okay, so we would go x times x is x squared, x times 2 is 2x, minus 4 times x is minus 4x, and negative 4 times positive 2 would leave us with negative 8. So simplify means removing the brackets and collecting like terms. So we'd bring down x squared plus 2x minus 4x. We're sitting at plus 2 on the number line. We're moving 4 places to the left. So we're going to end at minus 2x. And then we're going to bring down the minus 8. That's FOIL. Now, when we factorize, we are doing the opposite. Okay, so now when I say to you, factorize, I'm starting with x squared minus 2x minus 8, and I am putting in the brackets. So now we have to think of two numbers. When we multiply them, we get 8, but the difference between them is 2. So all of us know already that these two numbers have to be 4 and 2. So x and 4 and 2. So we do our cross multiply, we get 4x. We do our cross multiply and we get 2x. Now, before deciding what term, what sign has to go inside, we have to go back and we have to fetch our middle term together with its sign and put it underneath. Because if we want a minus 2x, all right, then which of the 2x or the 4x here, which one has to be the negative?
4.
The 4 has to be the negative, and the 2 has to be positive. And then it's this sign that you take inside here, and then that is your bracket. So here, the first bracket would be x plus 2. We take the minus, we put it in there, and then that one would be the second bracket, x minus 4. All right, so what I was trying to say to you, this is now type number 3 that we were talking about, okay? The middle term is negative and the last term is negative. One bracket has a plus, the other bracket has a minus. But of the two numbers, of the two factors that we used, if the middle term was negative, the larger of the two numbers is the one that had to have the minus sign. So that's why the minus sign belongs to the 4 in this case. Does that make sense? Can you see how factorizing and foiling are the opposite of one another? How are you feeling, grade 10s? Want to give me thumbs up, thumbs down? Is this making sense? Thanks, Harry. Thanks, Nizole. What about the rest of you? Don't be afraid to say if it doesn't make sense to you. Thanks, Lizzie. Thanks, Senentlantla. Okay, being able to factorize is one of, especially these trinomials, is one of the most important skills that you can learn in high school maths. You are going to be factorizing trinomials from grade 10, grade 11, grade 12, all right? And not just in algebra, you're going to see where it's applicable in other places in maths as well. Okay, so being able to factorize a trinomial is super, super, super important for you. Okay, so let's go back and go and have a look at the other questions. And again, of course, if there's anything you want to ask me, then please do. All right, so obviously wrong way. Okay, so that was those two. Then they could give us a difficult one like this to factorize. Now this has one. Sorry, David. I think your phone's ringing. Okay, this one, what's this called? This expression, y minus xy plus x minus 1. What's that called? Does anybody know? It's not a trinomial because there aren't 3 terms in it. It's not a binomial because there aren't 2 terms in it. So what's that called?
Quadrilateral.
Close, but not quite. Quadratic, no, it's not quite. Quadratic means it's got the highest power is to the power of 2. This is actually called a polynomial. Is that a word you've heard before, grade 10s? A polynomial. Okay, so that's 113. So in English, poly, if a word starts with poly, it means many. Okay, so we have monomial for 1 term, binomial for 2 terms, trinomial for 3 terms, and anything with 4 or more terms we refer to as a polynomial. Yes, there we go. See here, 100%. Algebraic expressions that consist of variables and coefficients. Quite right. Speaking about variables and coefficients, if I say to you, this is a variable, that's a coefficient, this is a constant, do you understand all those terms? Grade 10s, do you know what a constant and a coefficient and a variable is? Should we just talk about that quickly? Okay, so Megan, I don't know if you wanted to talk about it or you don't. Okay, all right, well, let's just, okay, that's fine. Let's talk about it, not a problem. Okay, because these are very important things, all right? We can't, it's like they are the tools for the job, all right? So when it comes to, where's my pen now? There it is. When it comes to algebra, that's fine, Nizole, don't worry. Oh, Sihle, you are too funny. Okay, so in algebra, okay, let's talk first about a variable. Okay, so now in English, the word variable comes from the English word which is vary, to vary. And that means the word vary in English means that it can change. So in other words, a letter is going to be a variable. Variables are letters. So variable is just a fancy word for saying a letter, because letters can change their value depending in which context we use them. Okay, so like when we solve an equation, sometimes x can be 2, but sometimes it can be 3. All right, so variable is just a fancy way of saying a letter. Okay, so things like x or y or ab or any letter that we use, okay? A coefficient, okay, is a value, normally, usually numerical, that the variable is multiplied by. A value that a variable is multiplied by. So if I say something like, here is an algebraic expression, 2x, then x is the variable and 2 is the coefficient. All right, so coefficient is a value that the variable is multiplied by. So if I write 2x, I mean 2 of x. Okay, 2 of x. Right, and I'm allowed to write it like that, 2x like that. Coefficients can be positive or they can be negative. So I could also have something like this. If I could have minus 3x plus, minus 3y plus 7x. So in this expression over here, there are two terms. It's a binomial. The coefficient of y is negative 3. The coefficient of x is 7. Does that make sense, guys? Do you want to, yes, no, thumbs up, thumbs down? Okay, thanks, Lesejo. Makes sense. Oh, good. Okay, good job. Okay, now the other thing that you need to know, another word, thanks, Sam, thanks, Lizzie. Another word that we need to know when we talk about algebra is the word constant, a constant. So a constant is like the opposite of a variable. Constant means does not change. It means it stays the same, does not change. It's always the same, okay? So in other words, that is a number, because no matter what context I use positive 2 in, it always means plus 2. If I say minus 7, it always means minus 7 no matter what. So constants on numbers on their own with no variables. Okay, so numbers on their own. With no variables. Okay, so that's a constant, a coefficient, and a variable. What I'm just going to quickly show you now is, okay, so here, if I write x, okay, it means positive 1x. But you don't have to write the 1 in front. You don't have to write the plus sign. But if you write negative x, it means minus 1 times x. Okay, so negative y means negative 1y, except we don't have to write the 1. We would just write it like that. Okay, so in this case, all right, here the coefficient is negative 1. Here the coefficient is negative 1. The variable there is x, the variable here is y. Now, let's say I decide to come along and I write 3x on its own. That is called a monomial. Okay, so a monomial is a one-termed algebraic expression. Okay, and it has one term in it, consisting in this case of a coefficient and a variable. The coefficient is 3, the variable is x. But I can do this. So I can take my 3x and I can add 7 to it. Okay, it's not going to change. It's going to stay as 3x plus 7 because they're not like terms. And now I would call this a binomial.
Lee,
I'm just busy teaching.
okay, babe, I'll leave the scratch for you on the door.
Thank you.
Okay, bye.
But- Perfect. Thanks very much. Sorry about that, grade 10s. It was my neighbor coming to be nice to me. Okay, so 3x is the first term and 7 is the second term. Terms are separated by plus and minus signs. So here there are two terms. The first term is 3x. The second term is plus 7. The coefficient of x is 3. The variable is x. The constant is 7. We call this kind of expression a binomial. Okay, now in English, if a word starts with bi, it means two, like bicycle, 2 wheels. Now, a trinomial, like the ones that we were working with. A trinomial can be something like x squared minus 2x plus 15. But it can also be something like x plus y minus 7. Those are both trinomials. So the word trinomial means a 3-termed. So here there are 2 terms. And here there means there are 3 terms. Okay, so terms are separated by plus and minus signs. That's really important for us. First term, second term, third term. First term, second term, third term. Okay, when it comes to writing a term in algebra, we always write it as sign, number, variable. Okay, so if we have a look here, positive 1 x squared, sign, number, variable, stop. Next term, sign, negative, number 2, variable x. Do you understand that, grade 10s? Right, over here, plus 15, no variable in this one. Again, sign, number, variable, sign plus number 1, variable x, sign plus number 1, variable y. Next term, sign minus number 7, in this case, no variable. That's because 15 and 7 are constants. Okay, so it's very important that you understand what a term is. And a collection of terms is called an expression. So a trinomial is an expression, an algebraic expression with 3 terms. A binomial is an algebraic expression with 2 terms. Okay, is that a little bit clearer on all the definitions? Everybody feeling a bit better now? Okay, cool. Yeah, because I mean, we can't, algebra is a language. You know, and we can't speak the language of algebra if we don't know the correct words to use. Okay. Anyway, I hope that helped a little bit. Let's go back. Pleasure, Sam. Pleasure, Lesego. Let's go back and go and have a look. No problem, Marisa. Hang on. Where am I going here? Oh, there we are. Let's go back and have a look at what we were talking about, right? So here there are 4 terms in this expression. Now, I don't know how much opportunity you guys have had to work with factorizing something that has 4 terms in it. I mean, if things like number 1.1.1 or 1.1.2 are a little bit difficult for you, then 1.1.3 is even a little bit more difficult than that. Here, because it's a polynomial, if we want to factorize this, we've got to do it by something called grouping. Have you heard that before, grade 10s? Factorizing by grouping. Does that sound familiar? Yes, says Sam. Cool. Okay, so yes, okay. No problem, Tanika. Okay, so by grouping, we mean by using brackets. Okay, so we have to first insert brackets into the expression. All right, so we would do it like this. Let's just move that out the way and let's give ourselves some space to write. I'm going to put it over here. Okay, so we have got our expression is y minus xy plus x minus 1, right? When we group, what we want to do is we want to group together either 2 terms, and sometimes you can even group 3 terms together, but fortunately here they want us to group 2 terms together. So by grouping, this is what we're doing. We're going to put a bracket and we're going to write y minus xy, and then we're going to put another bracket, plus another bracket, x minus 1. Now, if I were to remove these brackets, essentially I've got 1 in front. So 1 times y is 1y, and 1 times negative xy would give me negative xy. And then here, plus 1 in front of the bracket would give me plus x, and positive 1, positive invisible 1, times negative 1 would give me negative 1. So if I remove the brackets, I get what I had in the line before. The only thing that I can do here, grade 10s, is to take a common y out of the first bracket. I am left with 1 minus x in my brackets, plus x minus 1. Now I have a little problem. My little problem is this. In this bracket at the front, my 1 is positive and my x is negative. Here at the back, my x is positive and my 1 is the one that's negative. So now I need to do something called a switch round. Have you heard that? A switch round. Some teachers have got other names for them. Okay, so a switch round involves manipulating a sign. So what I'm going to do is I'm going to leave the first term as it is, and what I'm going to do here is I'm going to change that to a minus. Okay, exactly. And now I'm going to have 1, and then I'm going to put that minus, and then I'm going to put x. Now, why does this work? It works because negative 1 times 1 is negative 1. Look here, positive 1 times negative 1. I haven't changed the sign of 1. If I remove the brackets in this line over here, or that line over there, the 1 would still be negative. The x in the purple line, so in this line over here, is positive, and it's still positive here because a negative times a negative is a positive. So a switch round is just a clever way of manipulating an expression in order to be able to take out a highest common factor. Exactly, Nizole. So we've changed it to minus x plus 1. Oh, this is what you were asking about, Marisa. Ah, okay. Well, I'm glad we did this question. Okay, so here we go. All right. So now we're going to take out 1 minus x as our highest common factor. What's left? It's going to be 1 minus the invisible 1 in front of that. Okay, so what you need to see here is that this is actually one where it's so easy it's difficult. Here is the first term. Here is the second term. Okay, so we're taking 1 minus x out of both. What we're left with is y minus 1. So in other words, if we split these apart, we'd have y times 1 minus x up here, and then negative 1 times 1 minus x over there. And that, grade 10s, would be your final answer. Okay, so yeah, maybe that's what you were referring to, Marisa, was something like this with grouping that you then have to go and do a switch round. Okay, so you guys have gone very, very quiet. How are you feeling? Is this good? Is it bad? Where are you at? Cool, Harry. Thanks, Sam. Are you sure, guys? Okay, Tanika, thank you. There are no questions. 100% says Sam. Thank you. You understand, Lizzie. Okay, good. Good stuff. And Toby saying you're quiet. Thanks, Marisa. David, you're also very quiet tonight. Are you okay? Thank you, Senenhlanhla. Sihle, you've also gone quiet. You're all right. Okay, I'm glad Ntavi's saying. Okay, that was simplify. Oh, you had a late connection. All right. So this is the first question. This is on factorizing, and the second one is simplifying. Okay. So now, if we have a look, this is the main difference between the two words. Can you see, grade 10s, when they tell you to factorize? When they use the word factorize, everything is terms. Can you see here? The first expression has 2 terms in it. The second expression has 3 terms in it. The last expression has got 4 terms in it. And you are factorizing because you are putting in the brackets. Look here. Okay, so can you see in the first one, we put in the brackets. Okay, so the only thing that okay, so Sihle, maybe we must spend a whole lesson talking about trinomials because they are so important. We'll just see how everybody else feels. Okay, do you see how we put in the brackets in 111? In 112, where did we do it? There we go. Can you see how we put in brackets? Everything is inside brackets, okay, except for things that are on their own. Right? All the pluses and the minuses are inside the brackets. And then look here in the last one. Again, all the pluses and minuses are inside the brackets. That's what we're doing when we are factorizing. Simplifying is the opposite. Simplifying is easy. Simplifying means removing the brackets. Okay, so if I have a look at question 1.2.1, when they tell us that we want to simplify, everything is already inside the brackets. We're going to remove the brackets. All right, and we're going to end up with terms. Okay, so when we factorize, we start with terms, we end with factors. When we simplify, we start with factors and we end with terms. Right. Now, do you guys know how to multiply this out, a binomial with a trinomial? Are you able to do that on your own? Can you tell me?
Yes, ma'am.
You can do that.
Mm-hmm.
Okay, Sam, that's cool.
I know, ma'am.
Okay, that's fine. Not a problem. Let's do it together then. All right, so Sam, if you want to go ahead and do it on your own, that's okay. There are other people that are saying, no, they're not sure how to do this. Okay, so what we are doing, let's just make some space for ourselves, is we are being asked to multiply. We're being asked to multiply x plus 2 with x squared minus x plus 3. So this is how we do it, okay? First, we start with the x, and we have to multiply the x with every other term in the other bracket. So x times x squared is going to leave us with x cubed. Exactly. And then I'm just changing colors to hopefully make this a little bit easier with you. Then we're going to take the x and we're going to multiply it by the next term. So positive x times negative x is negative x squared. Positive times a negative is a negative. 1 times 1 is 1, and x times x is x squared. Sign, number, variable. Okay. Next one, we're writing terms, sign, number, variable again. So let's choose a different color. Let's go plus 3x. Good job. Okay, so x times positive 3, sign, number, variable. Good, well done. All right, and now we do exactly the same thing with the 2. All right, so going underneath, we're going to say 2 times x squared. So sign, number, variable. Let's pick a different color. Yeah, good. Over here, minus. So negative times a positive, minus 2x. Let's pick a different color. Last one, positive 2. Remember, we are multiplying. Positive 2 times positive 3 is plus 6. Okay, not plus 5. Remember, we have multiplied. Exactly, Namusa. Good job. And now we've got like terms. Okay, so x cubed, there's no other. Okay. But does it make sense now, Sihle? Can you see where the pluses and the minuses came from? What we were doing is we were using our rules. When we multiply a positive with a positive, we get a positive. A negative times a negative is a positive. And when we multiply a positive and a negative with one another, we end up with a negative answer. Okay. Good stuff. Now, collecting our like terms together. There is nothing like the x cubed. X cubed has no other friends. It's on its own. But here is an x squared term and here is an x squared term. This is why you've got to look at the sign in front. Here we are starting at -1 on the number line and we are adding 2. So if we start at -1 on the number line and add 2, we will end at +1 x squared. Okay, now we have simplified or reduced our x squared terms. This is why we call it simplifying. And then it's the same with our x terms. We're starting at +3 and we are taking away 2. You cannot ignore the sign. Okay, so +3x minus 2x, we will then end at 1x on the number line.
Sorry, ma'am.
And then, yes.
How come my negative x squared and plus 2x squared is equals to positive x squared? Isn't
No
it supposed to
problem.
be negative?
Okay, Sam, no problem. Minus x squared plus 2x squared. If we ignore the x squareds for now, and we say that this is -1 plus 2, here's our number line. There's -1, there's 0, there's 1, there's 2, there's 3. Where are we starting? We're starting at -1 on the number line. When they tell us to add, they're telling us to go in this direction. By how many? By 2. 1, 2 to the right. Okay, that's why we're going to end at +1. Okay, yes. Okay, does that make sense to you? So really what you're doing here is that you're not just combining like terms together, you're also working with integers. Okay, so this is why your integers are so important as well. Okay, how are we feeling? Is this making a little bit more sense to you? Do you want to do some more algebra next time? Do you want to focus on trinomials and on factorizing? What are your thoughts, grade 10s? How would you factorize the answer? You don't need to worry about that, Nizole, until you get to matric. Okay, when you get to matric, you will have to factorize cubics. All right, so Riabetswe. Okay, Sam. Okay, so Riabetswe, a bit more practice then on this. Can we have more next time? Okay, and Tabiseng, that's fine. It's okay, says Ntondo. All right, not a problem. All right, so we'll focus on algebra again the next time. We'll talk a bit about factorizing. We'll talk a little bit about simplifying, and then hopefully we can also practice solving some equations. Okay, anyway, unfortunately, this will be the last time this happens. The matrics write paper 1 tomorrow. See here, because ma'am, I can do information. It does, Cecily. One mistake and it ruins everything. Oh, well done. Oh, thanks, Ria Betswe. Well done for writing all of that down. And of course, you can come and you can watch this lesson again if you want to do. Nawaz, I'd like to do more trinomials and polynomials. Cool. Thank you so much for all your feedback. This is really great that you tell me this, because then at least I can structure these lessons to suit you. I mean, there's no point me wafting on about all sorts of things and then it doesn't actually help you at the end of the day. All right. And then we'll also fit in some paper 2 stuff. This is, as I was saying, this is the last lesson where the matrics are going to be after you. They write paper 1 tomorrow. So unfortunately, I have to disappear now and go and help them. But for the rest of our lessons for the rest of this month, I don't have to skedaddle 1 or 2 minutes earlier. Namusa, talk to Coco. She'll help you with where you can download this lesson. I'm going to love and leave you now, and then I'll see you guys next Tuesday. Okay, take care, grade 10.
Thanks, Lee. You need to hurry.
Okay.
Bye.
Yeah, have a good weekend. Bye. Bye, everyone.
Bye, ma'am.
Hi, everyone. I just saw your lesson. It looked so hectic, but I hope that you guys are doing okay. For some reason, I cannot for the life of me find what I need to now screenshot for you guys, or what I need to then share. Let me see if I can do this proper now. Oh, there we go. Okay. There we go. Okay, guys, I won't keep you long because we are kind of out of time. So we're just going to look at what you guys are going to be doing with Lee in the next lesson. So today's lesson was functions. I know, guys, like Lee said, the first 2 sections, algebra and functions, are very, you guys don't understand, they're so important. You're going to be using these things all the way to matric. So please try to practice as much of them as you can, as many different ones as you can, to make sure that you get the right answers. Okay. But yeah, thanks so much for joining us, guys. Practice, practice, practice. We can't say that enough. You know, maths is all about practice. You can't just sit there and watch. You need to do it yourself. But good luck, guys. We're going to see you all next week, Tuesday. All right. Bye, everyone.